हेलो फ्रेंड्स, सो आज हम पढ़ने वाले हैं लाप्लास ट्रांसफॉर्म। अगर एफ टी इज़ अ फंक्शन ऑफ टी डिफाइंड फॉर ऑल नॉन नेगेटिव वैल्यूज ऑफ टी, देन दिस इज द लाप्लास ट्रांसफॉर्म ऑफ द गिवन फंक्शन एफ टी. So this is the main that you need to remember, and it is also denoted by capital Fs. Let us see, क्या हम हर एक फंक्शन का लाप्लास निकाल सकते हैं या फिर कोई कंडीशन है. सो द सफिशिएंट कंडीशन फॉर लाप्लास इज, सो पहली कंडीशन है दैट एफ टी इज पीस वाइज continuous. Okay, and the second is the function is of exponential order alpha. Fine, so these are the two conditions for the existence of Laplace. So okay, so let us see कि भाई कोई फंक्शन है जिसका लाप्लास नहीं मिलता. So if you consider this Laplace of tan t, then इसका लाप्लास नहीं मिलता. क्यों? बिकॉज ये पीस वाइज कंटिन्यूस नहीं है. और सेकंड है लाइक लाप्लास ऑफ ई टू द पावर टी स्क्वायर, तो उसका भी लाप्लास नहीं मिलता. क्यों? क्योंकि वो उसका एक्सपोनेंशियल ऑर्डर ही नहीं है. सो आपको बेसिकली ये याद रखना है. इज दिस क्लियर? दिस इज द मेन डेफिनेशन ऑफ लाप्लास ट्रांसफॉर्म. ओके, सो आई थिंक अब आपको लाप्लास की डेफिनेशन पता चल गई है. सो लेट अस मेक एन अटेम्प्ट टू ड्राइव सम स्टैंडर्ड लाप्लास ट्रांसफॉर्म ऑफ सम एलिमेंट्री फंक्शन. सो लाप्लास ट्रांसफॉर्म of some basic elementary function. ओके, सो एक बार देख लेते हैं कि कैसे ड्राइव करने हैं, एंड आपको बाद में ये सब याद रखने हैं. लेट अस परफॉर्म देम वन बाय वन. ओके, तो सबसे पहले लेते हैं लाप्लास ऑफ 1. सो आवर फंक्शन इज एफ ऑफ टी इक्वल्स टू 1. ओके, सो द डेफिनेशन विल बी यूज. सो Laplace of 1 will be what? Integration 0 to infinity e to the power minus st into ft, and ft is what? 1 dt. Correct? Now what we need to do? We need to integrate this. So integration of e to the minus st is what? E raised to minus st upon minus s, and we need to apply the limits, that is from 0 to infinity. Now it will be nothing but upper limit minus lower limit. So it is to the power minus st, that is infinity, divided by minus s, and this will give you plus e raised to minus s multiplied by 0 divided by s. Now you must be thinking that how to find the limit. So this will be 0 and this will be 1 over s. Okay, so let us look for the graph of exponential function. So it is something like this, correct? Yes. So if you go on the left hand side, correct, this way, so it will become 0. So that's why it is 0. Hence we have got the final answer, that is it is 1 over s. So Laplace of 1 is 1 over s. Okay, so let us move to the second one. So let us find the Laplace of t to the power n. So you can consider this one as important also. So Laplace of t to the power n will be what? Integration 0 to infinity e to the power minus s t multiplied by t to the power n dt. To solve this, let us put the substitution. So put st equals to x. So this will give you s dt will be nothing but dx, and hence dt will be dx over s. So let us put it back. So limits will be 0 to infinity e to the power minus x, and it will be nothing but x by s raised to n, and at the place of dt we will be writing dx over s. Fine, so you can see that we can take out the s common, s outside, so it will be 1 over s raised to n plus 1. So I have taken the n from this and 1 from here. So this will be 0 to infinity e to the power minus x, and x to the power n dx. Now you can compare this thing with gamma function. Okay, I hope you remember. So gamma n is nothing but 0 to infinity e to the power minus x and x to the power n minus 1 dx. So this is the gamma function. So clearly you can see that. So we can write this as 1 divided by s to the power n plus 1 and gamma of, yes, this is n minus 1, so it is n. So we are having n, so it is going to be gamma of n plus 1. So this is the, that is gamma n plus 1 divided by s raised to n plus 1 will be the Laplace of t to the power n. And you can also remember that gamma n plus 1 is what? N factorial, if n is a positive integer. Now let us move towards the next one. Third, Laplace of e to the power minus at. Fine. So this will be again Laplace of e to the power at will be what? 0 to infinity e to the power minus st into e to the power minus at, which is the given function dt. So if we combine these two terms, what we will be getting? 0 to infinity e to the power minus s plus a t dt. Now we know that integration will be e to the power minus s plus a t divided by minus s plus a, and the limits will be 0 to infinity. So if we put the limits, what we will be getting? It will be nothing but e to the power minus s plus a infinity divided by minus s plus a, and it will be plus कर देंगे हम बाद में e raised to minus s plus a times 0 divided by, this will become plus s plus a. Now again we know that this will be 0, correct? If you remember the graph, so this will be 0 plus, and this will become 1, correct? It was 0 divided by s plus a, sorry, this will be a, correct? So this will be simplified to 1 divided by s plus a. So this is the Laplace of e to the power minus at. Fine. Similarly, you can prove that Laplace of e to the power at is nothing but 1 upon s minus a. So you can see that if this is negative, so this is positive, and if this is positive, then you need to put it as negative, correct? Okay, so let us consider the next one, that is somewhere and again an important one. So it is Laplace of sine at and Laplace of cos at. Fine. So we will be proving them together. So let us move towards the proof. We know that Laplace of e to the power at is what? It is nothing but 1 upon s minus a. Fine, we have just proved this one. And if we put a as iota a, fine, we are making a substitution. So what it will become? It will be nothing but Laplace of e to the power I at will be 1 upon s minus iota times a, correct? Now we know that we are having a complex number in the denominator, correct? So we need to remove that one, correct? Okay, so how we will remove that one? Like multiplying by its conjugate in the numerator and its denominator, correct? So Laplace of e to the power iota at will be 1 over s minus iota a into s plus, sorry, this will be s plus iota a divided by s plus iota a, correct? Because that was a complex number, so we have multiplied and divided by its conjugate. So this will be what? Yes, it will be, so it will be s plus iota a divided by, that is a minus b and a plus b, so it is a square minus b square, so it will be s square plus a square because of that iota, correct? So now what we can do, we know that e raised to iota at is nothing but cos 80, correct, plus, yes, it is cos 80 plus iota sin 80, correct. Now what we can do, we can compare the real and imaginary part. So by comparing real and imaginary part, correct. Okay, so let us make it down. Yes, so what we will be getting, yes, we will compare the real and imaginary part. So e raised to iota t will be replaced by cos 80 plus I sin 80. Okay, let me erase this. Sin 80 will be what? Yes, we are having a relation is, yes, this is s plus iota a, s plus iota a divided by s square plus a square, correct. So if you compare, what you will be getting, yes, that will be, yes, this will implies Laplace of cos 80 is nothing but s upon s square plus, yes, it will be s square plus a square, and Laplace of sin 80 will be what? A upon, yes, it will be a upon s square plus a square, correct. So these are the Laplace transform of the given function. Similarly, we are not going to for the fifth one, but yes, you can derive them similarly. That is for Laplace of sine hyperbolic 80, and it is nothing but, yes, it will be a upon, yes, you need to make some changes over there, correct, a upon s square minus a square, fine. And Laplace of cos hyperbolic 80, fine, that will be what? Again, you need to make some changes in cos 80. It will be, yes, it will be s upon s square minus a square, correct. So these are the two that you need to perform by your own. So for that I am helping you out. You know that sine hyperbolic 80 is nothing but, yes, it will be e to the power 80 minus e to the power minus I80 divided by 2. And for cos hyperbolic 80, it will be e to the power, yes, 80 plus e to the power minus I80 divided by 2, correct. So I hope that the proofs are clear. So let us summarize the things together. So this is the table that you need to remember, and all the transformation that we have performed, you need to remember them. Okay, remember them by heart, because we will be needing them in the next session to find the Laplace of different transformation. Okay, so I think the things are clear. Thank you so much for watching, and please remember the following Laplace transform.